So what is statistics? Statistics is the science of collecting, organizing, summarizing, analyzing, and interpreting data to make decisions. So you first of all, you collect your data, then you organize your data, you put them in a way that will make you can understand the data. Then you summarize the data. Okay. So you summarize the data, you do your analysis, and then from your analysis, the results you get, you do your interpretation of the data to take some decisions or gain some insight. So how relevant is statistics to you guys as MLS people? Well, it can help you to analyze patients' test results for diagnostic accuracy. It can help you to conduct clinical trials to improve treatment. It can help you to monitor disease trends in public health studies. It can also help you to support lab control processes. So what are some examples of statistics in MLS in your area? Let's say you want to calculate the mean glucose level of diabetic patients in a hospital. If you make an effort to calculate the mean glucose level of a diabetic patient or diabetic patients, a number of them, let's say you've taken about 20 patients, you have figured out you've tested for and seen their level of glucose. So you put them, all of them, their level together, then you've tried the mean or the average. Once you are doing that, you are applying statistics in your field. You can also use it to analyze blood test results to predict anemia prevalence. Okay. Now let's look at the types of statistics. Okay, the types of statistics. Two main types. We have the descriptive statistics and the inferential statistics. Now, what is descriptive statistics? It is a type of statistics that summarizes and describes the characteristics of a data set. Okay, so some examples may be you want to know the average hemoglobin levels of patients in a clinic. That is a characteristic of a data set. So the data set in this particular example is hemoglobin levels. So let's say you consider patients who come to your facility and then you take note of their hemoglobin levels, let's say 20 or 30 patients. You consider all of them, then you strike the average. Once you find the average is like a characteristic of that particular data set, okay? Because for hemoglobin levels of 20 patients, you can find who has the highest hemoglobin level, which level stands out the most amongst patients, what is the average hemoglobin level. All those things are trying to find the characteristics of hemoglobin levels of patients, which is the data set, okay? Right, so the second point, another example is creating a pie chart to show the distribution of blood types in a population. All right, so let's say your class, MLS evening students, if we ask each of you, what is your blood group? Are you A? Are you AB? Are you O? Are you O positive, O minus, and all of those things? We pick all that information. Picking that information, when I now have the information in my hands, that information is what we call data, okay? Now I have that data, I can create a pie chart for that data. So in that pie chart, I will see that, okay, so maybe 20% of the class is A, 50% is O, and then 30% is AB. No, let's all B. Is there blood group which is B? I'm sure. Anyway, this is an example. Okay, so these are the ways that you can use descriptive statistics in what you study or in the work that you do. You can also construct bar graphs to display infection rates of different wards in a hospital. Yeah. We are moving on to inferential statistics. What is inferential statistics? Inferential statistics use sample data to make predictions or generalizations about a population. Okay, so you may have an entire population. We'll come to defining sample and population, but in the meantime, let's say your entire class, you're about 80 students. So I want to know something about your class, okay? Now, instead of taking information from every single one of you, I pick about 20 of you randomly. Then I pick that information. So let's say I pick 20 of you, I ask for your ages. And then I find that the average age of those 20 people I picked. Remember, I said there are 80 of you in the class. Now I select only 20 of you. I ask for your ages, then I find the average age. So as I'm saying, I will say that the entire population of the class is 80 students. Now I'm picking a sample of 20 of you, only 20 students. I'm going to ask of your ages. Okay. When I get the ages, I'll find the average of the ages. So I'll have 20 ages. I sum all those ages, I divide by 20. Now, I may have my average age as 30, which means the average age of these 20 students is 30. Now, based on this, I'm going to say that, okay, if I pick 20 students randomly and their average age is 30, then I'm just going to infer and say that the average age of MLS evening students is 30. So you realize that I didn't ask for all 80 of you. I used just 20 randomly. And then based on the value I got, I'm inferring that then based on this, I can say that the average age of the entire class is 30. So that's what we mean by inferential statistics. You use a portion of the population to make a study, get some findings, and then you apply the findings on the entire population. So example, predicting the prevalence of diabetes in a region based on a sample. That's another experiment you can do. Estimating the effectiveness of a new drug using data from a clinical trial. Okay. So yeah, if a new drug comes, you don't take the entire batch that they have produced and test them. You only pick a sample. You pick just about a few of the drug they brought. Then you test. When you test and you see that it reaches the standard you want, assume you infer that okay, because the ones we picked have met the standard we want, then we know that the entire batch they have brought will meet the standard we want. So then you have inferred. Great. Some methods that are used in inferential statistics are hypothesis testing, confidence intervals, regression analysis. Okay, so what are some of the limitations of statistics? Some key limitations are that statistics is focused on aggregate and ignore individual cases. Okay, so sometimes you realize that we are looking at the group. Look at what I said by average age. The average age being 30 doesn't mean that you are all 30 years old. Someone is 20, someone is 40, someone is 35. So you realize that we're always looking at the group as a total, the group. But we ignore individual cases because if I base on the fact that, okay, the average age is 30, and so I say that, okay, for 30 years old, this may be their need. But there's a 20-year-old in the group. That's the 30-year-old need I am providing. It may not be that 20-year-old's need. Okay, so maybe the 30-year-old, I may think for 30-year-old class, okay, maybe you guys are interested, you need jobs. But for a 20-year-old, their need at the time may be further education, wanting to further the education after what they are doing, not necessarily getting a job. So sometimes we end up ignoring individual cases when we are applying statistics. Another limitation is that the results depend on accurate data collection and sampling. If you are doing statistics, and you do not collect the right data, or you make mistakes in collecting your data of the sample, your entire results will be flawed because you're making decisions based on a wrong or a faulty foundation. The foundation is the data collection. So the key things to note here is that statistics is essential for making data-driven decisions, and then it helps summarize data. While descriptive statistics help summarize data, while inferential statistics help make predictions. All right, so on the reflection question, and my question was, how can you ensure that statistical findings in medical research are reliable and accurate? So I think you can reflect on it. Okay. I would say one thing I would say is that thinking about it, I think that one way of ensuring that statistical findings in medical research are reliable and accurate is that make sure you collect data. Your data collection is very accurately done. So if you are taking people's blood samples, make sure you do it well. Make sure the test results are well done. I mean, the test is very well done and the results are accurate. That way, when you are applying statistics, you know that your results are most likely to be. I like it to be very close to being accurate because the data you collected was also accurate. Yeah. Now let's look at some of the terms in statistics. We have the first one is population and sample. And yeah, we want to know what these two mean. All right. So what is population and what is sample? A population is the entire group of individuals or items you are studying. So for example, all patients diagnosed with diabetes in a region. And a sample is a representative subset of the population. So for example, 100 randomly selected diabetic patients from the region. Okay. So you have the population, all patients with diabetes in a particular region. So let me choose, let's say this is the central region. Okay. This is the region, the map of the region. Now, there are so many facilities in there. Let's say so many, all these dots represent the hospitals in central region. So in each of these hospitals, we have patients that have been diagnosed with diabetes. Now, in these hospitals, if I want the population, I would say that I'll go to each of these hospitals. Then I will take note of all patients who have been diagnosed of diabetes in all the hospitals. Now, if I choose just 100 patients from this hospital, I'm choosing just a portion. Okay, just a portion of the people who have been diagnosed as having diabetes. I'm choosing just a portion of it from the entire population. So this is what you will call your population. And this is what you will call your sample. Population is the entire group. Sample is a subset of the entire group. Just keep this one in your mind. Population is the entire group. Sample is just a portion of that entire group that you will use for the study. Parameter and statistic. We define a parameter as a numerical measure that describes a population. Okay, a numerical measure that describes a population. And then statistic is a numerical measure that describes a sample. So we are here again with population and sample. Now, if I am working with the entire population and I find, let's say, so if you want to know the true average, an example of parameter is the true average hemoglobin level of all patients in a hospital. I'm repeating, the true average hemoglobin level of all patients in a hospital. So you consider every single patient in that hospital, then you find their average. That is, you've considered the entire population in that hospital. Now, if I find the average hemoglobin level of 50 randomly selected patients in the hospital, so definitely there are more than 50 patients in that hospital, maybe about 1,000 or 1,500, 2,000, I don't know. But if I select, so let me say the entire population is, let's say the population, the entire, all patients in the hospital together is, there are 1,000 patients, okay? Good. Now, if I select only 50 randomly, and I find the average hemoglobin level, that average hemoglobin level for these 50 people is called a statistic. Now, don't confuse this with the entire course title being statistics. No, it is just a measure that is describing a sample. In this particular example, the measure is describing is the average. Okay. Okay. Okay, so now let's look at survey and census. Okay. So take notes. This is a method of collecting data. Survey is a method of collecting data from a sample of the population. It is a method of collecting data from a sample of the population. Okay. So the survey is that activity where you collect the data from a sample of the population. But census is that activity of collecting data from the entire population that are connected to your study. Right? Surveys are faster and of course less expensive because you are covering a smaller group of people. Yeah. But then for population is a lot. Look at what happens when you are doing a national population census. It can take a lot of time and resources because you are trying to cover all Ghanaians. So yeah, that's the difference between survey and census. So survey and census is still connected to sample and population, but this is the activity of taking the data from the sample and then the activity of taking the data from the population. So let's look at the pros and cons of survey and census. Surveys is quite similar to the pros and cons of sample and population. Surveys are cost-effective and time-saving, and they are suitable for large populations. Of course, if the population is very large, you had better use the sample than a survey. Otherwise, you will use forever to do your study. But there are some disadvantages too. There could be sampling bias in the course of collecting the sample. And the results you get are estimates because you are using a portion of the population to get a result. And that result would now be inferred for the entire population. So you will not get exact values. That's also another disadvantage. But advantage of census provides complete and accurate data. Of course, once you are using the entire population, you will get accurate data because you are covering every single member of the population. Okay. However, census can be very time consuming and very expensive. Sometimes it's very difficult to get access to the entire population. Okay. So now let's look at the source of statistical data. So we have spoken a lot about data, collecting data, and all of that. Where do we get the data from? Okay, what are our sources? So there are two main sources. We have primary data, and then we have secondary data. Let's try to understand what they are. So take notes. Two main sources of statistical data. One, primary data. Two, secondary data. Now, what's a primary data? It is data collected directly by the researcher for a specific purpose. Okay. So based on the kind of study you are trying to do, you collect the data yourself directly on the people you want to study. Some examples may be blood test results from a clinical trial. So maybe in your lab, you want to understand something. So as the patients come, you collect the data you need from them as they come until you get the data you need to do your study. What is an advantage of primary data? Data is very specific and relevant to the study. Because you target a group of people specifically for the study you are doing, you realize that that data is very relevant to the study that you are trying to do. Another advantage is that there is high accuracy when you collect it very well, okay? But there are two disadvantages I'll talk about. There are many more, but I'm talking about just two here. The first one is that it's time consuming and can be expensive because if you have to yourself collect data, sometimes you have to travel to meet the people you want to collect data from or to study the items you want to collect the data, you want to collect the information about. So it can take time and it can cost you too. And it sometimes requires skilled personnel and resources, okay? There are times that you have to, because maybe if your sample size is big, you need to get people to help you, and those people should be able to do the task. For example, if you're collecting blood samples from people, about 500 people, you can't do it alone. You need to get other people to help you. And you can't come and tell me to go and help because me, I can't draw blood. So it has to be a skilled personnel or somebody who is trained. So that's another disadvantage of using primary data. Now let's look at secondary data, which is the other type of source of data collection. Data collected for another purpose, but is used for the current study. Okay, so for secondary data, that data has already been collected in the past and it was used for some different study. But you are about doing a new study and you think that even though it was collected sometime in the past, it can still be used for your own study. So you simply pick that data and then you use it instead of going directly to collect the data yourself one by one. Then we are saying you are using secondary data. So example of such data is the, let's say, hospital patients records. All right. So you may go to a lab where they already have records. They have records already of patients. You just pick that record and then use it for your study. In that case, you don't have to sit there, meet patients one by one and collect data fresh. It was already collected and stored in the past and you're using it. You can also get data from national health statistics, from published research articles, and many other sources. Advantage of secondary data is that it is cost effective and it is readily available. okay? Because you don't have to now meet people individually or do the testing one by one. No, the data is already up. You just pick the data and use it, and it's available. It's also useful for large scale and historical analysis. Of course, if you are doing historical analysis, you can't go into the past to take the data. So you have to use data that's been stored already in the past, and that's what you use. But there are some disadvantages. One is that it may not fully meet your research objectives. Okay. So because it was collected in the past for some different research, even though you think that you can use it for yours, it may not be exactly what you need. So it may not fully meet the research that you are trying to do. Okay. All right. Now we are moving on to variables. The question is, what is a variable? Now the word variable means any characteristic, number, or quantity that can be measured or counted. A variable is also any characteristic that can take on different values at different times. If you look at patient's gender, we are saying that an example of variable is patient's gender. Okay, the gender could be female, male. So you realize that based on who I work to, if I work to, let's say, Gabriella, the gender will be what? Female. Okay. But if I work to, let's say, a J or a Japan, if I work to a Japan, the gender will be male. So based on who I approach, the gender changes. All right. So we are saying that gender is a variable because it can assume different values or characteristics at different times. Okay. Right. Now, they can also be blood glucose level is also a variable because based on who you test, you get a different level of blood glucose level. And then many other examples we can talk about. Looking at the types of variables, there are two main types of variables. We have the qualitative variables and the quantitative variables. So what are qualitative or categorical variables? These are variables that represent categories or groups. You can't really assign numbers to them. So for example, blood type, we have blood type A, B, 0. These are qualitative. You cannot assign numbers to them, as you can see. Test outcome. If you test for anything, let's say malaria, it's either positive or negative. So if I test for, let's say malaria, I'm going to get either positive or negative. So you can see that you can only group the outcomes into categories. All right. Gender, we have male, female. Now let's look at numerical or quantitative variables. These are variables that can be measured numerically, which we can assign numbers to them. And there are two main types. We have the discrete, we have the continuous. Discrete is countable values. Numbers are like number of chairs in the classroom, number of students in the class, number of cells in a sample. You can actually count and get a specific number or an integer. But continuous variables, you only measure them. They are measurable. Someone's weight can be 65.2 kg. Someone can be 75.33 kg. So you can measure, but you cannot necessarily count because you realize that continuous variables can take on numbers between two integers. If I say my weight is 65.2, that's a number line between 65 and 66. Okay, so they are only measurable, but they are not necessarily countable. There are other examples here of discrete and continuous variables.